Hi everyone, welcome again. We are discussing what is derivative. In this particular video, I will explain derivative with an example and then we will implement using Python programming. Let's say we have a function f of t that represent height of a bouncing ball as a function of time. Okay, so we have a function f of t here. You can see minus 4.9 t square plus vt plus h. So here t is your time, v is initial velocity, and h represent height basically. So what we are trying to tell you. So basically what's happening here. So let's say this x-axis represent time and this y-axis represent height. So height we can compute using this function basically. That is a f of t. So uh, if you're bouncing a ball, so it will start going up, and then after reaching at certain point where velocity is going to be the zero, it will start decreasing basically. Okay, that means what? It will go up and then it will come down with respect to the time. Okay, so our task is to find out the velocity of the ball over the time basically. So if I will say that what will be the velocity at this point, or I can ask that what will be the velocity at this point. I can ask what will the velocity of this point basically. Are you getting my point? Basically velocity is what we are trying to understand, that if height like with respect to time, okay, how your velocity is changing. Okay, are you getting my point? So basically we are trying to find, let's suppose if I'm saying that this is time t point 0.3 and I will ask that what will be the velocity at this point. Can you tell me? So to find out this kind of stuff, we need to understand the concept of derivative basically. Okay, in short, we can say that we are interested about this point. Okay, so what is the change with respect to this change? Okay, so if let's suppose basically what is a I'm really sorry. So let's suppose this is a height. This is a complete height f of t. So like this very small height y. Okay, and with respect to time, we are trying to find out the slope basically. That means what? We are trying to find out the this thing. Are you getting my point? So we need to understand like what will be the slope at this particular point. If we can understand, if we can find out the slope at this particular point, we can tell that what is the velocity. Okay, basically. Okay, let's come to the point. So how to find out the derivative? We are not yet studied it, but we can find out the derivative. So we know that to find out the derivative of this function. So this is going to be the this is the x power n formula we'll apply here. So this is going to be the minus 9.8 t plus. So here we will come outside and with respect to t, if I will differentiate t, this is bit only one, and h is a constant, so that is going to be the zero. Okay, so what are our task? Well, our task was to find out the velocity of the ball at each moment in a time. Okay, so how basically are you getting my points? I can ask that what will be the velocity at this point. How you can find out it? So for this you need to find out the slope basically. Okay, basically rate of change you are trying to find out actually. Okay, so how you can find out it using the concept of differentiation, using the concept of derivative. So you can take the derivative of the function with respect to the time. So this is going to be this thing. Okay, so this derivative represent the rate at which height of the ball is changing over the time basically. Okay, which is also known as a velocity of the ball. Understood? Okay, got my point. Okay, so now you will put the value of t and initial velocity. Okay, it will tell you what is the velocity of the ball at particular time. Okay, so if you are passing 0.3 in this equation, and let's suppose your initial velocity is 10. So based on that, you will get the velocity. So if the velocity value is positive, that means what? Ball is moving upward, otherwise it is going downward. Okay. So what we are trying to understand, okay, we are trying to understand what is a derivative basically. So derivative nothing is, it's the slope basically. Okay. So here in this example, we are trying to find out the uh, velocity of the ball at each moment of the time. Okay, in the time. Okay, so I can say what will the here, what will be the velocity at this point or this point. So any point, at any point I can ask it. Okay, are you getting my point? uh, you can take this as example as a COVID one also. So if somehow if you can generate a COVID, like let's suppose there's a y-axis and this is x-axis, this is a cases and this is a with respect to time, and somehow if we can say that our COVID cases are increasing exponentially. Okay, and then I can ask that what will be the what will be the rate at which cases are increasing at time 4. Okay, this is a day, let's suppose instead of time I'm making it day. So at day 4, what will be the rate of change by which cases are increasing actually? So how we can find out it? We can apply the concept of derivative, but for that we need to understand the function of cases. So if it is a y equal to e power x, so we will differentiate it, and then for that one, so we will find out the derivative of it, and then based on that we will compute it. Okay, so let's forget it. So basically we are trying to understand derivative is nothing, it's a kind of slope, and basically it's giving you the how something is changing over the time. Okay, okay, let's implement it also, so you'll better appreciate it. So to implement this concept, what we're doing actually, so we are using NumPy and Matplotlib, and then we're initializing two things here. One is what is the initial velocity and what is the initial height of the ball. Okay, you can take anything here, and then since we are going to plot like this, okay, or plot look like this. So one will be the height. So height is what? Basically you have a function for the height. This is a height basically over the time. So for the t, that is your x-axis, so we are generating time between 0 to 1. Okay, so I am plotting here, and with respect to each time your height will go like this, and then after some time it will drop it. Okay, so here in this case we are starting height with 10, so it will start with the 10. Okay, and then we are differentiating also. Why we need differentiation? Because differentiation, because that will be the slope for this particular curve. Okay, we need slope if you want to understand like how your curve changing over the over the time basically. So for that reason we need a derivative of the given function, derivative given curve actually, you can say like this also. So this is a this thing. Now we are going to plot two graph here. One will be the height, okay, over the period of time, and other will be the velocity, okay, how it's changing. Okay, so now see here, one is this is a height one, and now this is a velocity. See, if you see the diagram, you can understand. See, both are starting with 10. So as time is increasing, you can see your height is increasing. Okay, it's very obvious, like if ball will go up, so velocity is not going to be increased. Okay, it will start decreasing. Okay, and it will reach at some point. At that point, this will start dropping. Okay, so it's very easy, like you can see now your velocity will start going into negative. Are you getting my point? So that's we are trying to explain here in the first point. Okay, like if the velocity is positive, we can say that ball is moving upward, otherwise we will say it's a moving downward basically. So in summarization, what we're trying to tell you, if something is changing over the period of time, let's suppose this is a curve of that one, and I will say that what will be the rate of change of this function at this point? Can you tell me? So for that thing you need to find out the slope at this particular point. Okay, you need to find out the slope of this curve actually. And how you can find out the slope? Okay, There is a one simplest way is that tan theta equal to m. By this thing you can compute it. Okay, but for this reason you need to understand, you need to you need theta value. If you don't have theta value, so how you can go with, so now like you are using the concept of differentiation. Okay, by using the concept of differentiation you are able to find out the slope basically. Okay, so in the differentiation there is something called first principle. By using that one you are finding the slope basically. So we will discuss it later on. Okay, so hope you are able to get to my point. So basically, in short, we can say that the derivative represent the rate at which height of the ball is changing over the time. So here I'm just explaining in terms of example. You can take in general also. Okay, hope you understood my point. So I can show you an example. See this diagram. Okay, so here what's happening. So what I'm trying to explain here, if I will say that what will be the slope, okay, at this point. Okay, so basically if you have any circle, okay, and I will say that uh if you want to slope basically, so everything start with a tangent. Okay, so you want to find a perfect tangent. So for this circle, if I will say that like can you draw a tangent? You can draw it easily. So you'll from the center you'll draw a line like this, and then you can do like this. Okay, so this will be tangent for it. So it's easy for here. But if I will say here in this case, like I will ask, uh, can you draw a tangent? So there will be multiple tangent. Okay, this is not only one tangent. So one tangent can go like this also. Are you getting my point? One tangent could be like go like this also. So this is not an easy things. Are you getting my points? To how to solve this problem basically? Okay, basically what I'm trying to tell you. So at this point, at this black one point, there is not only one tangent. Okay, there could be multiple tangent. So we need to optimize it. So uh, we want a we want a base tangent at this point, so that we can say that this will be our slope. Okay, with respect to this tangent. So how we can do it? So basically, let's suppose we don't know. Okay, so we are starting with some point. Okay, so here in this diagram you can see we are coming from this point and we are trying to optimize it. Okay, so step by step we are trying to come closer to this point basically. So whenever I say closer and closer, so basically we're talking about the limit. Okay, so we are trying to come closer at this point. Okay, but that is not exactly at this point, but we are trying to come closer at to this point basically from the both side. Okay, and how we are achieving it? By using the first principle of differentiation. Okay, I'm not going to explain how to prove first principle of derivative, but basically it's happening. Like this diagram is a perfect example how you are computing the derivative. Okay, for that particular point. So if you want to find out derivative at this point, so basically what's happening, you are starting at some point and you are computing the different if you are computing the limit from the both side. Okay, so let's come to the point, then it will be easy for us to explain. Okay, so before going to the uh, explaining first principle of differentiation, let's discuss some application of differentiation in machine learning. Okay, so the very first application is like that we use differentiation to optimize our model's parameter. What do you mean by optimizing model parameter? Okay, so let's suppose okay, so I'm not taking any fancy machine learning model. I'm going with the simple. Let's suppose we 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 have one function pred y. Okay, so let's make it easy. Y pred, and here we have two variable. Okay, and we have some coefficient w1 and w2, and we have wn. Okay, and we have some y true also. Okay, so using this one we are using some loss function. Okay, so what we try to do in machine learning, we try to minimize our loss. Okay, we always want that our prediction need to be very close, or should be very similar kind of a true value. Okay, we cannot say like our prediction is saying that 0.5 but actual value is 1.7, so this is like loss is so high. Okay, so how we can minimize it? So to minimize this thing, we use the concept of differentiation basically. Okay, so how we do it? So basically, we are doing the same thing. Okay, so let's suppose instead of having multiple W value, let's suppose we have only one. Okay, so if you have multiple W, so we can go 3D and something like that. Okay, so let's suppose I'm using the simplest one. So in W1, let's suppose this is your loss function. So loss function on y-axis. So as you are increasing or decreasing some value of W, so let's suppose loss is also decreasing. Okay, so I can choose like this is my optimal value for W1. At this point my loss is very minimal. Okay, so this is a use case of the differentiation in machine learning. Apart from this thing, in the neural network, okay, so if when you implement any uh, deep learning model, so okay, so in that one there is something called back propagation. So back propagation is doing the same thing actually. Okay, so like you are updating your weight. So here weight is like this coefficient basically. Okay, you are trying to update the coefficient of your neuron. Okay, we can also use like we also use differentiation in auto dip. Okay, so hope now you are in the better position to understand like why we really need to study differentiation, because we have lots of use cases. Okay, so okay, let's come to the discussion again. So we were saying that using the first principle, how you can compute the derivative. Okay, so basically what we're trying to do, so if this is a curve and if I will say that what will be the derivative at this point. Okay, so we don't know it's a circle, it is not a circle. Okay, so if it was a circle, we can easily do like this. From the center we can find out a tangent, and we can say that how we can like we can easily find out the slope. But here that there will be multiple tangent. Okay, this could be one, this could be other one, so we don't know what is the optimal tangent. So for that reason we are using the concept of limit. So basically if we want to find out the slope or tangent at this point, tangent line at this point, so how we can do it? So we are using the concept of first principle. So basically what we're trying to do, so we are selecting one point, random point this, and we're trying to come closer to this A point basically. Okay, and how we are achieving it? Using the concept of limit. So let's suppose you have a function x square. Okay, so we have a function x square. Okay, and now what is the formula of first principle? Basically what we're trying to do, limit, this is a formula. Okay, this is a f of x plus h minus f of x divided by h. Okay, and here x is like at what point you are planning to find out the tangent. Okay, or derivative. So here I have written two different function. One is like one just preparing your function, so that is f of x, and other is like preparing your formula for the first principle. And then you are uh, just declaring couple of variable like what will be the point at which you want to draw tangent line, and then you are computing the derivative. So what you are passing, you are calling the derivative function, and then you are passing two things here. One is your function and other is your at what point you want to find it. At what point you want derivative. Okay, and then we are just finding the coefficient, and we are because uh, we want to plot it also, so we are computing x value and y value and the tangent value also. So now see here, so this is your curve. At this point we are trying to find out the derivative. Okay, so by using the first principle of derivative. Okay, so if you will change it, let's suppose you want to find out at point 2, so you can do like this also. Okay, so if want to change it, 0.5. Okay, so now see, this is changing. Okay, so hope I'm making some sense here. Okay, so if you don't know, like I'm not deriving like the formula of first principle. You can go through the some of the online tutorial where they will teach you, or you can refer it from other website also, where they will explain you first principle, like how it's working internally. But in short, I can tell you, we are we are just using the first principle formula here to implement our Python code. Okay, we are not explaining the how first principle work internally, but in short, I can tell you, like if there is a curve, and if you want to find out uh, at this point, so what we're trying to do, we are selecting any random point, let's suppose C and let's suppose B, and at A you want to find out this tangent. So what we're trying to do, we are approaching it from both side, and we're trying to find out the best tangent one. Okay, so hope I'm making some sense. So this function you can use to compute the derivative of any function at particular point. Okay, so you can replace with sine, cos, okay, whatever you want to do, you can do it and you can compute it. Okay, so hope I'm able to explain you differentiation concept. And using this formula we have the list of formula in the derivative, like what is the derivative of sine x. Okay, we have a rule. Basically, what do we know a rule? So if I will say that if there is a function x square, so what will the derivative of it? This will be the 2x. So how I am reaching at this point? Using this formula itself. Okay, so it's like when we do differentiation on pen paper, using pen paper, we cannot do this thing again and again. Basically, what we're doing here, we are trying to solve the limit problem. Okay, so when we do it on pen and paper, we cannot solve limit again and again. So based on that things, we come with some formula. So what is a formula? If there is a function in this format, x power n format, so derivative of this one, this is going to be the power will come, and then you will reduce power by 1. So in future, if I will say that there is a function x power 9, so the derivative of this function will be 9 x power 8. So I'm using this formula. So if there is a function x square plus 3x, so how? So differentiation will be uh, okay, so this will be 2x plus, so here 3 will come outside because we are not differentiating 3, we are just differentiating x. So dx by dx, this will be 1. Okay, so we'll come to this point. Okay, we'll solve many differentiation problems, so you will better appreciate it. But in this particular video, I was just trying to explain you, like, okay, how you can implement this thing into the Python one.